Hello, good morning students. How are you? I'm Francis sir, and today we will be studying elimination of trigonometric ratios. Okay, so here we have one question. Okay, let's see how do we solve these type of problems. Okay, so the first question, we have, if tan theta plus sin theta equals m and tan theta minus sin theta equals n, and we have to prove m square minus n square equals 16mn. Okay, so let's see. So first of all, we will take this, the left hand side, and what does the left hand side say? LHS equals m square minus n square whole square. Okay, we see that the bracket term, it is in the form of a square minus b square. Yes, so it can be written as bracket m plus n whole bracket m minus n whole square. Okay, so now we will replace this m with their respective trigonometric value, and that is bracket tan theta plus sin theta plus tan theta minus sin theta, bracket open, tan theta plus sin theta, you see, plus minus minus tan theta minus minus plus sin theta, bracket close, whole square. Now we need to solve this bracket term. So tan theta plus tan theta, okay, it will be how much? 2 tan theta plus sin theta minus sin theta. This both will be cancelled. Similarly in this one, tan theta minus tan theta, so these two terms will be cancelled, and then we have plus sin theta and plus sin theta multiplied by 2 sin theta whole square. So when we solve it, what do we get? 2 into 2, 4 tan theta dot sin theta whole of square. Then we have we will open the bracket, and what do we get? The square of 4, it will be 16, and the square of tan, it will be tan square theta, and the square of sine, it will be sine square theta. So this is the solution for the LHS. Now we will go for the right hand portion, RHS. What is it? It is your 16mn. 16mn. So we'll replace the values of mn with their trigonometric value, and it will be 16 bracket tan theta plus sin theta for m multiplied by tan theta minus sin theta for n. On solving it, what do we get? You see that these two terms are in the form of a plus b multiplied by a minus b. So it will be how much? Tan square theta minus sin square theta in brackets. So we see that this expression is quite different from this one. No, the RHS solution is quite different from this one. So what do? We move it further. So how can we do that? We convert this tan in terms of sine and cos. 16 bracket sine square theta minus by cos square theta minus sine square theta. We take sine square common. 16 sine square theta bracket, what do we get? 1 by cos square theta minus 1. When we solve it, we will get 16 sine square theta bracket 1 minus cos square theta by cos square theta. We know that 1 minus cos square theta can be expressed in the form of sine square theta. Yes? So, 16 sine square theta dot sine square theta by cos square theta, which can be expressed as 16 sine square theta dot, what is this? Tan square theta. So is this expression equal to the expression of the LHS? Yes, it is. So we can say that it is equal to LHS, and hence it is proved. Okay, so this is the way we can go through the solutions of this type. We need to replace these values with the values that has been provided in the question. But sometimes we need to simplify the expression. Sometimes we need to simplify the expression so that our solution gets easy. Okay, please note it down. So here is our next question, and the next question, what does it say? If tan A is equal to n tan B, okay, if tan A is equal to n tan B and sin A is equal to m sin B, what do we need to do? We have to prove that cos square A equals n square minus 1 upon n square minus 1. So you see that the expression has two angles, A and B, whereas the resultant, the proof that we have, it is having only one angle, that is A. It means that we need to eliminate this B angle, no? The expression of this B angle should be eliminated. So we need to find a trigonometric identity, which resultant is 1, that is related to tan and sine. So we got two formulas. One is your sec square theta minus tan square theta equals 1, and another one is cosec square theta minus cot square theta is equal to 1. So if we see forward that if we consider this formula, then tan is okay, tan is present here, but when we see that this sine is here, sec is the reciprocal of cos, but cos is not present here, so this formula won't be applicable here. So when we go to this formula, we see that this cosec is the reciprocal of sine and cot is the reciprocal of tan. So in a way this formula is most suitable. This formula is most suitable, so we will try to use this formula, okay, for getting our solution. Okay, so let's see. First of all, tan A equals n tan B. Okay, so tan B equals tan A by n. Okay, after that, we need to get this into cot so that we can apply that formula cosec square theta minus cot square theta equals 1. Okay, so we will do the reciprocal on both the sides. So it will be cot B will be equal to n by n cot A. Okay, so it will be cot B equals n cot A. So we got this first equation. Then we get the second given. M sin B equals sin A. So it can be written as sin B equals sin A by M. Again we do the same. We will do the reciprocal on both the sides. So what we will get? Cosec B equals M cosec A. Now we can use the formula. Applying cosec square theta minus cot square theta equals 1. So we have cosec square B minus cot square B equals 1. So this is our equation 2. Substituting the values of cosec from 2 and cot from 1. From 1 and 2. M cosec A whole square minus n cot A whole square equals 1. So it can be written as m square cosec square A minus n square cot square A equals 1. Now we will change this into sine and cos, because what is our here? What we need to get? We need to get cos square A. So it should not be in the form of cosec, cot and sec. It should be in the form of sine cos. Okay, so let's convert it. M square by sine square A minus n square sine square A cos square A by sine square A equals 1. When we solve this, what do we get? We get m square minus n square cos square A equals sine square A. We have same denominator, so this will be subtracted directly and this sine square can be taken on the other side. Okay, now you see we need to get cos. Sine should not be there in the equation, so what do? we convert sine in the form of cos. And what is that? That is m square minus n square cos square a equals how much? 1 minus cos square a. What do we get? We do this cos square, we get into the other side, and this m square we move it to the other side. So when we do this, we get cos square a minus n square cos square a equals 1 minus m square. We take cos square common here. Cos square a common. What do we get? Bracket 1 minus n square, which equals 1 minus m square. Now we can take this 1 minus n square to the other side, and that time we get the result cos square a equals 1 minus m square upon 1 minus n square, and we see that we get the result which is equal to our RHS, 1 minus m square, 1 minus m square. Achha, if we don't get, we see that this expression, what do? We take minus common both the sides, on both the numerator and the denominator. When we do so, minus common outside, we get m square minus 1, and at the downside, denominator side, what do we get again? Minus common, and we have n square minus 1. So when we do this, minus has been taken common, both the minus will be cancelled, and we get the resultant. So in a way, cos square a is equal to m square minus n square upon n square minus 1. So this is the way this question has been proved. Okay, so this is the layout. Sometimes we need to think beyond the given. Sometimes we have to put something extra. For example, here we needed to eliminate tan this b portion, so that's why we use this formula. Okay, it is not always that means putting the values into the question we get the solution. Sometimes we need to think out of the box. Okay, note it down. So I hope you have understood. So we will come up with more of the problems of such in the future. So work hard and see you in the next video. Okay.